Good morning. Any question before we start? All right, we are on chapter 7. So, which is gonna be the last method that we cover to do economic analysis. This chapter is talking about internal rate of return. So we talked about the internal rate of return in Monday class. If we are given with a CFD cash flow diagram like this, we are gonna set net present worth equals to 0, but you can use the other equation like net present future or equivalent uniform annual worth equals to 0 and solve for the I, which provides this. So I'm using this for this case, and net present worth is negative 1000 plus 200. It's a uniform series of the payment. I'm looking for P when A is given, solving for I, and N is 3. Set it equals to 0, solve, find A such that it provides, it set net present worth equals to 0. And we call I as internal rate of return. This is what we covered so far. So, suppose you borrow $P from the bank. So, if you borrowed money from the bank at present time, you should put the arrow pointing up with the amount that you are borrowing from the bank. And over the next 10 years, you are supposed to repay back the loan at the uniform series of the payment of $8. So this is typical form of borrowing money from the bank or financial institute. Pointing up because you get the money, pointing down because you pay back the money over the future years. So suppose internal rate of return for this loan is I%. So you calculate, you set net present worth equals to 0, and you find the I value, which makes the net present worth equals to 0 for this loan, and it's I%. Now the question is, if I don't change the P value and A value by increasing the I, what's gonna happen for net present worth? Is it gonna increasing or is it gonna decreasing? So think about that, work as a class activity. Then I call you. So at I equals to, at I%, the IRR is I%, means net present worth is 0 at this interest rate. Now the question is, if I increase the I, I'm not changing P and A values. I'm not changing these values. I'm just increasing the I. By increasing the I, do you expect to have positive net present force or negative net present force. Number 29 is not. True. So by increasing I, you expecting, you expecting to get positive or negative? The question was by increasing the I, what's gonna happen to net present force? So decrease means negative. And why is that? Why it happened? Because
your interest is higher.
Okay, the interest is higher. Why it's decreasing the net present force? At this interest rate, the net present force is equals to 0. So if you look at the borrowing cash flow diagram, in borrowing always we have money, getting money at present time, paying back in future years. So if you increase the I, by increasing the I, you are gonna discount the future value at the higher rate. True? You don't touch this because it happens in present time. So by increasing or decreasing the I, nothing is gonna happen for P. But the present value of this future payment is decreasing by increasing the I because you are gonna discount the future payments or future payments at the higher rate. So by increasing the I, we discount the future payments at higher rate. So if you discount the future, so a net present force is present force of the benefit minus present force of the cost. So present force of the benefit is P. I don't change it by increasing the I. But by increasing the I, we discount the future payment at the higher rate, so means present force of the cost is decreasing. So if you decrease this, present force of the benefit minus present force of the cost is increasing, so it's gonna be positive at the end. Any question about this? Yes.
Are you able to show us a situation where, as I increase, that W decreases? Just like the other way.
Say it again.
Can you show a situation where
I
as you
increase-
increase I, NPW decreases? Net present.
The situation when I increasing or decreasing, sorry,
I increasing and NPW decreasing.
and NPW is decreasing.
Yes.
So it's gonna be, if you want this happening, you should look at, you went to the next class activities. So which is, think about same problem, except this is borrowing. Now you invest. So you put the money at present time in investment project. Since you put the money here, you expect it to get paid in future years. So the money that you will receive, it occurs at future years. So you can set the net present worth, find the I which makes this equals to 0, and say, okay, IRR for this project is I%. Then, if you increase I, nothing is gonna happen for the P because it's happening at the present time. Decreasing or increasing the I is not gonna change the P. But what's happening for the A, since A is happening in future years, you are gonna discount the future receipt of the money at the higher rate. So when you calculate net present worth, which is gonna be present worth of the benefit minus present worth of the cost, this is P and fixed, but present worth of the benefit by increasing the I is gonna decreasing because you discount this at the higher rate. So then net present worth is gonna be negative. Make sense? So let's back to the loan or borrowing case. If you plot net present worth versus I, at I equals to IRR, net present worth is gonna be 0. At any I greater than IRR, net present worth is gonna be positive, and at any I less than this, the net present worth would be negative. So this is the borrowing. Plot of net present worth versus interest rate. As we explained, by increasing the I, it's increasing, it's going to the positive side. By decreasing that, it's going to the negative side. For borrowing. For investments, is gonna be vice versa. I mean, it's gonna be in the opposite direction. By increasing the I, we get the negative net present worth, and by decreasing the I, we are getting positive net present worth. Good. It looks simple, but when I go to the next topic, which I'm going to compare alternatives 1 with alternatives 2 with applying IRR method, then this concept is useful, and you should know the difference between borrowing and investment. In borrowing, we get money at the present time, and in return we are gonna pay back in future years. In investment, you put the money at the present time and you get paid in future years. In borrowing, what do you like? You would like to have lower I. Lower I is more desirable. In investment, higher I. You prefer higher I. Or higher IRR. If that makes sense. So when you borrow the money, you would like to pay less interest, so you would like to have lower IRR. In investments, you would like to get to have a higher IRR. So let me start working on some examples then. So there is a corporation bond at the price of $1,000. So you paid $1,000 to buy this bond, and the face value for that bond also is the same. In this case, you get paid $1,000, and the life of the bond is 10 years, and you get paid $40 per 6 months. So the life of the bond is 10 years or 20 periods of time, because you get paid every 6 months. 1, 2, 3, 4. Every 6 months you get paid $40. You get paid, so I should go up. And you pay this, you buy this at $1,000, and at the end of period, which is 10 years from today, you get the face value, which is $1,000. If you buy the bond and keep it for 10 years, it's gonna happen like this. But you decide after 1 year just sell the bond. So after 1 year means this part. So if I draw the cash flow diagram for first year, you paid $1,000, you get paid $40, and you could sell the bond at the price of $950 to someone else. The question is, what would be the IRR for the original buyer? So the original buyer is gonna see this cash flow diagram. Set, I'm using this equation. It's easier for me to use this equation, but you can use equivalent uniform annual worth and set it equal to 0. Net present worth. I had negative 1,000 here plus $40. It's a uniform series of the payment. I'm looking for P when A is given. We are solving for I and N is 2. Plus, I get paid $950. It's a future value. I'm looking for its present value. I'm solving for I, N is 2. And set it equals to 0. Negative 1,000 plus 40 times P over A, I, 2 plus 950 P over F, I, 2. Set it equals to 0. Which I is going to give me this left side equal to 0? We try, we guess. So I start with, we can make a guess. You can start from 5%, I mean, because we have no idea what it should be. But if I try with 1.5%, the present worth is going to be this part is gonna be 1000.41, which is very close to the 1000. I can assume that the IRR is 1.5%. At 1.5%, the net present force of this cash flow diagram equals to 0. But this I is per periods of time, which is 6 months. So per 6 months. If I multiply this by 2 times 1.5, it's going to be 3%. This one is going to be annual percentage rate or nominal interest rate. Nominal interest rate. If we are looking for the I effective, it's going to be 1 plus percentage per 6 months, which is 1.5%, power 2, because we have 2 terms per year, minus 1. It's going to be 3.02. As I said, in this chapter, we are going to use whatever we have covered so far. So the interest rate that we saw, it's per period of time, and period of time is not year, it's per 6 months. So we expect to represent the I by its effective interest rate. We should know how to find that. So nominal interest rate, just multiply by 2. Effective interest rate, you should use that. Good? Any questions so far? This example is continuing to go to the next slide. So someone has purchased this bond at this price. So if we want to draw the cash flow diagram for that person, it should start from year 2, which is going to be now present time. 0 at present time, which is year 1. Sorry, year 1. It goes all the way to periods of time 18, which is 9 years from this time. 9 years later, this fund is gonna be expired. So how much the buyer has paid? 950. So 950, 1, 2, 3. So the buyer can get benefit of $40 for the remaining term, which is 9 years or 18 periods of time, plus this $1,000. You sold the bond to someone else. The new person, the new buyer, is gonna pay $950 to you to buy the bond, and it's gonna pay by $40 per 6 months and get paid $1,000 at the end. Now the question is, what would be the internal rate of return for the new buyer? The same approach. I use net present force. These are the same. Present force of the cost equals to the present force of the benefit. If you move cost to the other side, you set it equals to 0, you will get net present force equals to 0. But present force of the cost. Present force of the cost, it's 950. Present force of the benefit, we have uniform series of the payment of 40, A times P over A, I N is 18 pairs of time. We get another benefit, which is the buyer gets another benefit, which is 1000 P over F I 80. A is 40, F is 1000. Again, try with 5%. At 5%, the benefit, the cost is not going to change because it occurs at present time. The benefit is going to have the value of 883, which is less than 950. We should increase the present cost of the benefit. As you see, the benefit occurs in future. If you want to increase this, you should decrease the I. So the next I should be lower than 5 because you want to decrease this. You want to increase this to 950. I'll try 4%. I will get something close to 1000, but you want something equals to 950. So I is going to be between these two. I don't show the process, but by linear interpolation, you will find IR of 4.43% per 6 months. It's very important. It's per 6 months, not per year. If this is 4.43 R or nominal interest rate is 4.43 times 2, which is 8.86% nominal. And effective interest rate, effective. Is 1 plus R dividing by 2 power 2 minus 1. R is 8.83 dividing by 2 is going to be 4.43 power 2 minus 1. It's going to give me 9.05. So effective interest rate for the new buyer is 9.05. So the first buyer got 0.02, second buyer gets 9.05. Any question on this? All right. We can look at the corporation who issued the bond. If the issuing corporation paid 1% fee to sell the bond, what would be the interest rate, the IRR that the company has paid? So just the same thing, except the seller gets $1,000 here. You paid $1,000, but the seller is going to get $1,000. But they should pay 1% of that, which is 1% of 1,000, which is $10. So it's gonna basically they will get 990. 1,000 minus 10, 990. The rest will be the same. They pay $40 for 10 years or 20 periods of time, and they pay another $1,000 at the end. Just do the calculation. 990 positive minus find the present value of these future payments and try the different I and end up to IRR 4.077. If you want to find R, I is going to be 8.14, 50. And I effective is 8.32. So the corporation has paid 8.32%. As a point of view of investor, you would like to have higher I. You would like to get a higher I. But as a point of view of the corporation, you would like to have the lower I. So this is the difference between the investment and borrowing. So basically the corporation borrowing the money from you because they get paid, you pay them at the present time, in return they pay you in future years. So basically they borrowing money from you and they would like to have a lower I for this borrowing. Alright, these coming 3 or 4 examples are very important because we are going to go through the concept of incremental analysis where you are given with 2 or more alternatives and you would like to apply this method to find the best alternatives. So far you know if you are given with a single cash flow diagram, then you can find its IRR. But if you are given with couple of alternatives, alternative 1, alternative 2, you can find the IRR for this, you can find IRR for this, but you will see that you cannot compare the IRR for alternative 1 and alternative 2 and pick the greater one. It's not the right approach. The right approach is applying the incremental analysis that you will see later. So it's wrong that if you compare the IRR for the alternatives and pick the higher one. So it's not the right approach. So you want to buy a property. The price is 300K. You have 2 options to pay for that. Either pay 20% down payments and the balance should be paid in 5 annual payments at the rate of 12%, or pay cash with 10% discounts. So alternative 1, 20% should be paid at the present time. 20% of 300,000 is gonna be 60,000. So the remaining is gonna be would be 300K minus 60,000 is gonna be 240,000 remaining. Now you can pay this $240,000 in 5 annual payments. What would be that A? So present value is 240,000. We are looking for A. So if you are looking for A, P times A over P, I is 12% and N is 5. $240,000 this, it's gonna be 66,000. It should be 300K times 80%. So this 80% shouldn't be there. So the answer is 66,576. So let's look at the first alternative. You pay 60,000 here plus this $66,576 for the next 5 years. Second option, it says if you pay cash, you can have 10% discounts. So alternative 2, you pay everything at present time. $300K minus 10%. 300 minus 30,000. It's going to be $270,000. So if you pay $270K at the present time, you can get the profit. Now the question is, what is the internal rate of return for the loan offered by the seller? We are gonna do this. Set net present worth of alternative A equals to net present worth of alternative B. If this is alternative A, alternative B, or 1, 2. 1, 2, I mean. And solve for the IRR. What is the net present worth of first alternative? Negative 60,000. Negative 60,000 minus 66,576. It's a uniform series of the payment 1, 2, 3, 4, 5. I'm looking for its P. When A is given, we are solving for I. N is 5. So net present worth of 1 is this guy. Net present worth of 2 is negative 270,000. Okay, I move this negative 270,000 to the left side. Negative 2, it's going to be positive 270,000 minus 60,000 minus 66,576 times P over A I 5 equals to 0. 270 minus 60 is going to be positive 210,000, negative 66,576 times P over A I 5. Set it equals to 0. And find this I. If you divide this by this one, you will get this factor, which is 3.154, and I'll try with 15%, I will get 3.352. If I try with 18%, I will get 3.127. So this one is going to be between 18 and 15, linear interpolation. So I will get IRR 17.60. Now look at this line. I have a number positive which occurs at present time. I have something negative as a uniform series of the payment. It tells me this left side is gonna look like something like this. You get money at present time with the amount of 210K, and you have to pay back over the 5 years at this amount. So it tells me I'm gonna have a loan case when I'm looking at this borrowing. Because it has positive here, negative for the future payments. So when you are borrowing money, you would like to have a lower IRR. So 17.6% per year, it's quite high interest rate. You don't want to borrow the money, so you don't want to go for this. But what does it mean if you don't want this? It means if we back to this original cash flow diagram, these two. Which one you prefer to borrow money from the bank from somewhere out of this seller and pay this 270,000 with that cash, but you don't want to go with the loan which has been offered by the seller. So since it's too high for borrowing, you don't want to go to borrow money from the seller. You would like to finance this money from another source and not going with this option. Another example, there are two options to buy a parking permit. Either buying by annual permit, which needs 180 August, September, October, November, December, January, February to July. August, September, October, November, December, January, February, all the way to July. So the first one you pay annual permits at the August with paying $180. Second one you pay for 6 months by semester. So you pay $130 in August and another $130 in January at the beginning of spring. what we are gonna do, we set the net present force of 1 equal to net present force of 2. Net present force of 1 is negative 180 equals to, this one is negative 130, negative 130 times, we are looking for P when future value is given. What would be, how many months we are far from present? 1, 2, 3, 4, 5. So negative 180 plus 130 plus 130 times P over F I 5 equals to 0. Negative 180 plus 30 is going to be negative 50. Negative 50 plus 130 times P over F I 5. Set it equals to 0. Before I solve for I, when you look at this, if I ask you to draw the cash flow diagram for the left side, you will see one negative 50 at the present time, what, August, September, October, November, December, January, and one positive 130 in January, or 5 periods of time later. 1, 2, 3, 4, 5. $130. 0, 1, 2, 3, 4, 5. If I ask you, is it borrowing or investment? You can say, since we are paying something at present time and in return we get paid in future, it's an investment. So if you solve for the I, you will find I per month, because the period of time is months, is 21.06. And if you find the annual effective interest rate, it's going to be 891%. So if you are given the investment project which provides 891% benefit or internal rate of return, definitely you will go for this. So what does it mean? Compare these two. Which alternative needs higher initial cost? This one needs higher initial cost than this one. So it means if you compare these two, the alternatives with the higher initial cost means you pay something higher at the present time. So this one needs more money than this one. So for investment project, you would like to pay something extra or something out of pocket at present time, and in return you get paid $130. So you go with the alternative with the higher initial cost, which is annual payment. We continue on next Monday. I will post the homework today or